Okay, 39 is a tough problem right here. And one of the things I talk about a lot in Calc is that very often when we're making up problems for you guys to work on, we can either make the problem nice and pretty at the beginning, and then it often, very often, has a really ugly answer, or you can have a certain nice answer in mind and then work backwards, and you end up with a regular ugly-looking problem to start off with. And I think this is that second category. You've got this nasty function right here of what y equals the square root of 1 minus t squared plus the inverse sine of t. But if I remember this problem right, some cool things are going to happen that are going to make this derivative kind of interesting. The first thing I would probably do here, guys, is this square root of 1 minus t squared. I'd probably rewrite this as 1 minus t squared and have all that taken to the 1/2 power. Okay, I think that's going to make our derivative a little bit easier to come up with now. So I'm going to draw my dotted line, and we're taking now the derivative of y with respect to t. So here we go. We've got a binomial here raised to the 1/2 power. So I'm going to use the power rule on that, and my derivative is going to start with a 1/2 out in front, and then a 1 minus t squared. We drop the power by 1, so that now goes to the negative 1/2 power, and then we need to multiply by the derivative within. And the derivative of 1 minus t squared is going to be a negative 2t. So that chain rule there says we multiply that, and that's where we are for the derivative of the first term. Now, moving on to the derivative of the second term, this one's pretty straightforward, hoping we have these down by now. Derivative of inverse sine of t, that's going to be a 1 over, now the square root of 1 minus whatever your u is, which here is just t, and we square that, times the derivative of that ratio, but the derivative of t is just 1. So that's our derivative there, everybody, and so the calculus of all this is done. Now the question is, what can we do to clean this answer up? And there's some kind of cool stuff that happens here once we start playing around. So let's take a look at what's going on here. We've got a binomial right here raised to a negative power. That tells me that this first term is going to turn into a fraction. And that negative 1/2 power is going to become a square root in the denominator of 1 minus t squared. And maybe now you're looking ahead and you're starting to see where this thing is going, but I digress. We also have a 1/2 times a negative 2t. That's just going to make a negative t up there in the numerator. The 1/2 and the 2 cancel each other out. So, okay, that's the derivative of that first term now, and then plus a 1 over, and we have the square root of 1 minus t squared. Now, you probably didn't see it. I certainly didn't see it at first, but the way they gave us this problem, we ended up, without having to do any work, with two fractions being added together with a common denominator. So I'm going to combine those now, and I could make that numerator negative t plus 1, but I think it would be prettier if I wrote it 1 minus t all over that common denominator of the square root of 1 minus t squared. And I think with where we are right there, guys, that's about as good as this thing is going to get. I don't think they tried to split that up at all. So I'm looking at their solution, and sure enough, it's 1 minus t over the square root of 1 minus t squared. And that is dy dt for number 39. Fun little problem there.